Welcome to the Explainer. Today, we're zeroing in on something that absolutely caught my eye. It's this fascinating framework called PaperOrchestra. Now, if you've ever tried to get an AI to help you write a complex research paper, you already know exactly how messy that gets, right? It's like trying to untangle a giant knot. Well, let's dive into how this multi-agent system takes that massive, headache-inducing pipeline and actually turns it into a streamlined, submission-ready reality. Okay, let's look at our roadmap for today. We're going to start with the AI paper writing problem, move right into the 5-agent symphony, peek under the hood at the architecture, walk through the step-by-step workflow, and wrap up with final outputs and constraints. All right, section 1, the AI paper writing problem. So writing a research paper is definitely not just typing. It is a massive cognitive load. You're constantly deciding what to plot, verifying citations, drafting sections, kind of juggling it all at once. And look, a lot of us just expect to push a magic button and get a perfect paper out the other side. But in a single-agent reality, the AI just runs out of context halfway through, or it spits out this complete structural mess because it's trying to do everything simultaneously. But when you shift gears to a multi-agent pipeline, things completely change. You get specialized agents, explicit handoffs, and strict halt rules. Suddenly, the whole process becomes verifiable, and honestly, it actually works. Moving on to section 2, the 5-agent symphony. And this is exactly where PaperOrchestra comes to the rescue. It's based directly on Google's implementation from their paper, arXiv 2604.05018. What it does is decompose this massive paper writing task into 5 highly specialized roles. And the results? They are literally staggering. This 5-agent architecture achieves an incredible 50 to 68% absolute win margin on literature review quality over single-agent baselines on the paper writing benchmark. Plus, it scores a 14 to 38% win margin on overall paper quality. That is a massive leap forward. And this brilliantly illustrates why it works so incredibly well. PaperOrchestra supplies the instructions and the deterministic guardrails, while your chosen agent supplies the intelligence. It doesn't try to replace your favorite AI model. Nope, whether you're using Claude Code, Cursor, Clines, or Aider, this framework just provides the rigid rules so your host agent can actually focus on its real job, deep reasoning. Let's hit section 3, architecture under the hood. What's genuinely fascinating about how this integrates is that it packages these prompts as executable skills for your host agent. You literally don't need any extra API keys natively. There are no heavy LMM SDK dependencies to install, and absolutely no embedded LMM calls secretly hidden in the code. It just seamlessly uses your host agent's built-in tools to do all the heavy lifting, right inside your existing coding environments. To really understand this, think of every skill in PaperOrchestra as having 3 core components. First up, you have a skill.md file. That's a dense instruction document your agent reads and follows. Second, there's a references folder. That holds verbatim paper prompts from the original Google paper, JSON schemas, and grading rubrics. And third, you have the scripts folder. Now these are absolutely crucial, deterministic, local helpers. They handle all the rigid, mechanical stuff, like validating JSONs and untangling messy bibliography citations, which is known as bibtech deduplication. And they do all of this without making their own network calls, giving you rigorous structure totally locally. Now, even though no API keys are strictly required natively, you do have some super powerful optional integrations if you want to turbocharge your workflow. You could add a free Semantic Scholar API key to raise your rate limits when verifying those citations. You could also integrate PaperBana via Gemini or OpenRouter to generate really nice publication quality diagrams. And you can even hook up Exa as a dedicated research paper search backend. Again, all optional but absolutely game-changing tools. All right, on to section 4, this step-by-step workflow. So picture a typical day in the life of a researcher. Your notes are probably scattered across a dozen different agent chats and cache files, right? Well, PaperOrchestra features an optional aggregator skill that runs in 4 phases: discovery, extraction, synthesis, and formatting. It literally walks through your directories, extracts the data, synthesizes any redundant records, and then formats the whole thing into clean, structured inputs called idea.md and experimental_log.md. It essentially cleans up your mess before the actual writing even begins. So the crucial point is, once those inputs are nice and clean, the pipeline kicks off like a highly coordinated assembly line. It starts with the outline agent generating a structured JSON plan. From there, it branches out, running the plotting agent and the literature review agent completely in parallel. After they finish up, it brings in the section writing agent to draft the actual text, build your tables, and splice in those generated figures. And finally, it tags in the content refinement agent to do a rigorous simulated peer review. Let's zoom in a little bit on those parallel steps. The plotting agent is making around 20 to 30 LLM calls, and it even features an optional vision language model critique loop just to make sure those diagrams look completely right. Meanwhile, the literature review agent is also doing its own 20 to 30 calls. But here's the kicker. It doesn't just hallucinate random citations. It uses rigorous semantic scholar verification with a super strict text matching algorithm, the Levenstein match, to make absolutely sure real papers are cited. It actively prevents hallucinations and aims for a 90% citation integration rate. Pretty impressive, right? Section 5, Final Outputs and Constraints. So what do you actually get at the very end of this entire pipeline? You get a fully verified, submission-ready LaTeX paper that is formatted exactly to your specific conference template guidelines. We're not talking about a messy, plain text document here. It is a compiled, formatted, ready-to-submit piece of work. Now, when we compare PaperOrchestra to other alternatives out there, its unique selling points become pretty obvious. The biggest difference? Paper traceability. PaperOrchestra actually uses the exact verbatim prompts from Appendix F of that original Google paper, so it isn't just some opaque black box doing who knows what. Furthermore, it includes built-in paper autorators and benchmarks to measure output quality straight against the actual paper's rubric. With a lot of other tools, you'd still be stuck doing manual review. But hey, we really have to ask the important question here. What are the limitations and constraints? This is a highly specialized system, so what kind of guardrails do you need to be aware of before jumping in? Well, you've got to remember this is an intensive process. Expect high context consumption. We're talking about 20 to 30 calls per agent. You're also heavily dependent on your host agent's web search quotas. And importantly, those strict halt rules we mentioned, they mean business. The refinement agent will genuinely reject and revert changes if they don't pass its rubric. Your AI can't just smooth talk its way out of a bad draft. And lastly, just remember, this is explicitly for AI research papers in LaTeX format. It is definitely not designed to write your next blog post or general essay. I want to leave you with this final thought. The structure of PaperOrchestra is intentionally rigid. You've got the deterministic scripts, the halt rules, the exact prompts. But that rigidity exists precisely so your chosen AI's intelligence can be totally free to reason deeply about the actual science. The question is, will you trust an orchestrated pipeline with your next experiment log? It's a genuinely fascinating shift in how we manage AI coding agents. Thanks so much for joining me on this explainer, and definitely keep exploring the incredible potential of multi-agent workflows.